Hello friends, today we'll discuss about queue data structure or queues. So queue is a data structure in which we insert data from one end and remove data from other end. Also, the data which gets inserted first in the queue will be removed first. That's why sometimes queue is also called as first in first out data structure. So it's a first in first out, that is FIFO data structure, right? So to implement queue, we'll use abstract data type or a structure like this. So let's call it as a queue. Inside this variable queue, we have an array in which actual data will be inserted. Let's call this as data array. So 0, 1, 2, 3, and 4. So the end from which we delete data is called as front end, and we'll keep track of those front locations in a variable called as f, and the end from which we insert the data will be called as rear end, right? So when the queue is empty, when there is nothing in the queue, no data in the queue, front and rear both will be -1. So queue empty condition is front and rear both are -1. When we do first insertion, we make both front and rear 0 and insert a value there. Let's say 10. So front 0 indicates key the oldest value in the queue is at 0th location. The rear 0 indicates the new value or the latest value in the queue is also at 0th location. So for subsequent insertions, we increment only rear, right? So for example, if we insert one more value, I see what is r is 0, I increment it by 1, that is I make r equal to r plus 1. So 0 equal to or r equal to 0 plus 1, that's 1. So r becomes 1. I go to location number 1 and insert a number there. For doing other insertions, right, we again increment r by 1. So 1 plus 1 becomes 2. So we go to second location and insert a number there. Likewise, we do insertions in queue. So insert operation in a queue is called as enqueue operation, and removing the elements from the queue is called as dequeue operation. So if we do one more enqueue operation, so rear will be equal to rear plus 1. So rear is 2, it will be 2 plus 1, that is 3. So we go to third location, insert a number there, let's say 40. Now let's do some dequeue operation. To do dequeue operation, I see what is the value of f. F is 0, that means the oldest element in the queue is at 0th location. So I go to 0th location, delete a number from there, and then increment f by 1, that is f equal to f plus 1. That is, it was 0 previously, it becomes 0 plus 1 equal to 1, indicating the oldest element in the queue is now at location number 1. If you do few more deletions, let's do one more deletion. So for doing the deletion, we see what is f is 1. So go to location number 1 and delete number from there and increment f by 1, making f equal to f plus 1, that is 1 plus 1 equal to 2. So now with this, we have rear as 3 and front as 2. The meaning of this is the oldest element in the queue is at location number 2 and the latest or youngest element in the queue is at location number 3. Let's do few more enqueue operations, one more enqueue operations on the queue. So to do enqueue operation, we see what is r. R is 3, we increment it by 1, it becomes 3 plus 1, 4. Go to fourth location, insert a number there. Right. So now if we want to do further NQ operations, we see there is no space in the queue, right? The queue full condition here is when rear becomes the equal to the size of the array or the last location in the array, that is fourth location here in this particular case. So the queue is full. The queue full condition is rear becomes equal to the last location of the array. Right? So when rear is equal to last location of the array, we will not be able to insert in this array. Right? So let's write the functions to perform different operations on the queue. Right? So the first function which let's enlist the operations on the queue. The operations on the queue are I can check whether the queue is full. Right? Second operation, I can check whether the queue is empty. Right? Third operation is NQ operation. NQ means inserting elements in the queue is called as NQ operation. Fourth is DQ operation. Deleting an element from the queue is called as DQ operation. So let's write C programming functions to do all these operations. So let's write the first function full. Right? So the full function will return me 1 if the queue is full, otherwise it will return me 0 if the queue is not full. So int full, so that's why the return type is integer. So int full, to this full function I'll pass the queue. Right? The queue, the type of this queue is structure queue. So here is the structure which will require for this queue. Struct int. This queue has 3 elements. One is this data array, another one is this f, and this r. Right? So int data, let's say the size of the queue is 5, then this int front and r rear. That's the structure which will require in order to have such variables or such queues. Right? So when we create this queue, maybe let's say in any function or main function, for example, to create the variables of this queue type, we need to say struct queue. So queue is a variable of this structure queue type. So as soon as this queue variable is created or this queue is created, we need to initialize this queue. Initializing queue means setting front and rear to -1, indicating we have not inserted any value inside this queue, or we have just created the queue. So that's why the queue is empty, and we need to indicate it by setting front and rear to -1. That is called as initialization of the queue. In fact, that operation will perform first. That is called as initialization operation. Initialization operation. Right? So let's write the init function first, or initialization operation first. So it's void init. To this init function, I'll pass the queue which I want to initialize. So I'll pass it by reference struct queue star p. So my call to this init function will be like this. I'll show you a call here. So to call to this init function will be like this: init ampersand queue. I'll pass the address of the queue. So this is passed by reference or passed by address. So when I make this call, this address of this queue, for example, this queue is passed to this pointer, or in other words, this pointer p points to this queue. Sorry. So now in this init function, I want to set this front and rear to -1. So in init function, I know only a pointer pointing to that Q, so I should make use of that pointer. So by using this pointer P, I'll set front and rear to -1. It's done like this. Name of the pointer, arrow operator, and name of the member which I want to access, name of the member of a structure which I want to access. I want to access this F, so P arrow F will give me access to this F. So I want to set it to -1. Also, I want to set this R to -1. So I'll say P arrow R equal to -1. That's it. That's the init operation which will be performed, and it will set front and rear to -1. So the other operation which we need to perform on the queue is called as empty operation. Also, to this empty operation, we'll pass the address of the queue which we want to check for whether it's empty or full or whatever. So the empty function will return me 1 if the queue is empty, otherwise it will return us 0. So that's why the return type of empty function is int, because it's going to return 1 or 0, right? So return type is int. So int empty. To this empty function we'll pass the address of the queue, right? So we need a pointer which will point to that queue. So the address of the type of the queue is struct queue. So we need a struct queue pointer here, struct star p. Right? So let's check, or let's see how to make a call to this empty function. I'll pass empty. I'll call it the empty function like this, empty ampersand q. Right? So this sort of call I'll make to this empty function, right? If empty this queue perform something, right? Else perform something, right? For example, this empty function will be used while doing a dequeue operation, right? So that kind of call can be made to empty function. We are passing the address of the queue, so that address of the queue is stored in the pointer p, right? So the queue empty condition here is front or rear is -1. So I'll check that by using this pointer p. So if p arrow f equal to -1, that means the front variable is -1, the queue must be empty. That's the queue empty condition. So I'll return 1. Else I'll return 0. Either this return will get executed or this return will get executed, right? If this is true, that means queue is empty, will return 1, telling queue is empty. If f is not -1, will return 0, telling there are some elements in the queue is not empty. Then in the same way, we can write the full function. Full function will also, to full function also I'll pass the address of the queue which I want to check whether it's full or not. So full function will also return us 1 if the queue is full. Otherwise, it will return us 0 if the queue is not full. If there is some space in the queue. So the return type of the full function is int full. To this full function, again I'll pass the address of the queue which I want to check. So the type of the queue is struct queue. So that I need a struct queue pointer here, struct queue type pointer star p. So the queue full condition is the rear is equal to the size of the array. If the size of the array is 5, the last location will be 4. That means if rear is equal to 4, the queue is full. I'll return 1 in that case. So here, let's assume the size of the queue is 5, so the last location will be 4. So if rear is equal to 4, the queue is full. If p arrow r equal to, now here the size of the array is 5, but in general let's say the size of the array is max. So if p arrow r equal to max -1, if the size is max, the last location will be max minus 1. Okay? So if P arrow R equal to max minus 1, that means rear is pointing to the last location. That means Q is full, so I'll return 1 from here. Else I'll return 0. That's the Q full function. Now let's write the other functions like uh, NQ function and DQ function. So to this, the return type of this NQ function will be void because it will not return us anything. It will simply insert a value in the queue which is passed to this NQ function. So name of the function is NQ. It requires two things: the queue in which the value is to be inserted and the value which is to be inserted. So that means we need to pass address of the queue in which the value is to be inserted. If we are passing the address of the queue, we need a pointer to store that address here. So the first parameter to this NQ is a pointer, right? So the type of the pointer should be struct q because the type of the address which we are getting is struct q. So struct q star p, and the other parameter of this NQ function is the value which is to be inserted. Let's store that value which is passed in a variable called as x. So in fact, if we see a call to this NQ function, it will look like this: NQ ampersand q comma 5, let's say. So we are asking this NQ function to insert this value 5 inside this q. So let's write now the NQ function. So while doing NQ operation, I need to be little cautious. I should check whether it's my first NQ operation or is it some other NQ operation. If it is my first NQ operation, that means I'm inserting an empty queue. So while inserting an empty queue, I have front and rear as -1. So for the first NQ operation, I should set both front and rear to 0. Then I will NQ. So that's what I will check. If P arrow R or P arrow F equal to -1, that means I'm inserting an empty queue. So I should set both P arrow R and P arrow F to 0, and then I should insert in that location inside the data array. So now here I'm accessing the data array. So to access data array, I cannot access directly. I need to access by using this pointer. So P arrow data. Inside the data array, I will insert on the 0th location the value x, because P arrow R and P arrow F are 0. So the value should be inserted on the 0th location. And that is true when we are doing first insertion. Now, if it is not our first insertion, that means it is some other insertion, maybe fourth, fifth, or any other, right? So in that case, what I need to do is I need to first increment the value of R. So else, I'll write else here. So else, what will I do is I'll increment the value of R by 1 by saying P arrow R equal to P arrow R plus 1. So rear is incremented by 1. And then inside the array, data will go to rear location and insert the value x on that location. So we are going to data array, P arrow data, right? So inside data array, I want to go on rear location, the location which is there in R, right? But I cannot directly access R, so I need to say P arrow R. So this will give me the value of R, right? So inside data array, I am going on the location or to the location which is there in R. So P arrow data will give access to data array, and P arrow R will retrieve the value of rear. In short, it becomes P arrow data of some location is equal to the value x which I want to store. So that's it. That's a simple NQ function. So let's see here. So if this is our Q, F, R. So initially when Q is empty, F and R will be -1. So in that case, this will be executed. This if loop will be executed because rear is -1 means Q is empty. In that case, we'll set both these to 0, right, and insert the value here, right. Now if it is some other case, that means front and rear are not 0, not -1, Q is not empty, for example this particular case. So this else will be executed. We'll set this P arrow R. We have a pointer P pointing here, right, because we have passed address of this Q to this enqueue function, right. So what I'll do is I'll increment R value, right, so by 1, so R becomes 1 plus 1. So P arrow R will give me access to this R, and that is assigned P arrow R, right, the current R value plus 1. So 0 plus 1, it becomes 1, right. So that means we need to insert at rear location. So now this statement does the job. So P arrow data will give access of this data array. So we are now accessing data array, and inside data array, on which location we are inserting? Location which is there in R. So that R need to be retrieved, but I cannot directly retrieve it. I cannot write only R, but I have to use this P, right. So I'll say P arrow R. So in short, this statement will become P arrow data of 1 in this particular case, because this will return us P arrow R will give us 1. So we'll insert the next value here, and so on and so forth. So that's NQ operation. Now let's see the DQ operation quickly. So so the DQ operation, the return type will be int, because we'll be removing a value from the queue and we'll be returning it to the user, telling this is the value which is deleted from the queue. So that's why the return type is int. So int DQ. Again, the parameters which will be passing to this DQ is the queue from which the value is to be deleted, right? That's the only parameter we need to pass. So we'll pass the address, pass by address. So we need to have a pointer here, struct q star p, because we are getting address of a struct q type variable. So we need to have a struct q type pointer here. So once I have this q with me, so but again, while doing DQ operation, I should be a little cautious again. Am I deleting the only value in the queue? That means the value which I'm deleting is the only value in the queue. For example, like this. So let's say front and R are both 2. So when front and R are both equal, that means there will be only one value in the queue. So if we delete that value, the queue will become empty, right? So when the queue becomes empty, we need to set both front and R to -1. In this case, if we do in DQ operation, we are going to delete the value which is there in the location which is stored in F. So F is 2, so we'll go to location 2. We'll delete that value. And now if we delete that value, you see there is nothing in the queue. So queue has become empty. So we need to set both front and R to -1. So how I'll come to know that there is only one value in the queue? When front and R are same, there is only one value in the queue, right? So if P arrow R equal to P arrow F, that means both are same, F and R are same, I am doing the delete operation on the only value in the queue. So in that case, what will I do is I'll say x equal to, I need int x. In x is the variable in which I'll be storing the value which I'm going to delete, and later I'm going to return that value. X is equal to P arrow data of P arrow F. So I'm going to retrieve that value, and after retrieving that value, next I'm going to set f and r both to -1, telling the queue has become empty. And after doing this, I must return the value x to the user. So now if there are multiple values in the queue like this, queue is like this. So f is 0 in this case, r is 2. So in this case, f and r are not equal, so this part will not be executed. So then how will we do the delete operation? We'll see what is f. F is 0, we'll go to 0th location, retrieve the value, this value in x, right? And then we'll increment f by 1 by saying f equal to f plus 1, right? So else, what will I do is, I'll go to the location in the data array, which is there in f. So, and I'll retrieve the value from that location, x equal to p arrow data of p arrow f, right? So this will give me the value from the data array which is present on location f, and then I'll increment f by 1, saying the value on the f location is deleted and the oldest value is on the next location. Now that is one location in this particular case. So p arrow f is equal to p arrow f plus 1, right? Then return this value x, return x. That's it. That's the dequeue function. Okay. So uh, these are all uh, queue operations. So stay tuned to watch other videos on the chapters like queues, stacks, and other data structure chapters, C programming chapters, and C++ programming, and other technical topics. Thank you.